Welcome to a good day in the workshop, fixing a design problem. After the fiasco yesterday, I decided to make some modifications, starting with a larger water tank and fitting a new water tap, as well as a higher capacity number 4 injector. After piping this to the boiler, it should be an improvement. Analysing yesterday's fiasco, there were 4 problems. One was the tank wasn't big enough. I filled it with water, but when the overflow started to run, once I opened the steam tap, it emptied very quickly. The injector was a number 2, which is too small and didn't fill the boiler quickly enough. And also the steam tap that I was using as a water tap wasn't big enough to let sufficient water through. I did get the injector to pick up and inject water into the boiler, but in the time it took to make it do that, the water tank was empty. These were all contributory factors to a bad day in the workshop, and that's without the fact that one of the gas burners wasn't working properly. Oh yes, and I almost forgot, the horrendous piping has to go. And this is where the video starts. I'm removing this piping and I will dispose of it forever. When I fit the number 4 injector, it will be the correct way round. It's very important when disconnecting small Jubilee fittings injectors that you put union nuts on the end, otherwise the cones fall out, and if you lose them, then the injector is useless. I'm not going to throw this injector away. It will go back into my box of injectors for some future use on a much smaller steam plant. In this clip, I'm unbolting the water tank from the central stainless steel column. And here it is, complete with the water tap and the small injector. In this video, I'm going to show how to make a larger tank and fit a number 4 injector. I'll put the parts in a line so you can see the physical differences between them. From left to right, the original complete water tap and injector combination, followed by a silicone O-ring and a number 4 injector, and at the right hand side is a 5/16 by 32 steam tap, which will be used as a water valve and should pass sufficient water. I found a larger piece of copper tube, and here I'm mocking up the arrangement. The copper tube is sat on a piece of brass plate, and I'm using a steel rule across the top of the steam taps so I can get a level and make a mark. After this, I cut the copper tube to length using my metal cutting bandsaw. The metal cutting bandsaw cuts fairly well, but the top of it is not perfectly square. I took the piece of tube into the outer part of the workshop and cleaned it up on my 4-inch belt sander so that the cut end was perfectly at 90 degrees. In this video, I'm skipping through a few of the processes because they've all been shown before in my series A Model Steam Engine Test Plant. I roughly cut a piece of 3mm brass to a circular shape. I drew around the brass sheet using a felt tip pen and the copper tube. Then by repeatedly placing a steel rule across the edges of the black circle on the piece of brass, I found the centre. The next step was to drill a hole 7/32 of an inch, which is tapping size for 1/4 by 40 threads per inch. This threaded hole plays no part in the final assembly, but at this point it's very important. I'm using a tap guide to make sure the threaded hole is perfectly at 90 degrees to the plate. If ever you get bored in your workshop, make some of these for various tap sizes. They are incredibly useful. And here is a threaded hole exactly in the centre of the disc, or should I say in the centre of the black line. Next, I need to fit a modified boiler plug into this hole. It's the same one that I showed in the video series when I made the smaller tank. It's a boiler plug, but it has a centre drilled in it, which will accept my live centre so I can rotate this disc safely and firmly in the lathe. And here it is, fitted in the chuck of my Boxford lathe. And now I have to turn this disc to be a good fit in the bottom of the tank. Or should I say, to be a good fit in the bottom of the piece of copper tubing, because it's not yet a tank. You may be wondering, how did I know how much metal to take off? What I'm not showing is the fact that frequently I withdrew the live centre, turned off the lathe, and checked the fit inside the copper tube. At the moment it's still a bit tight. The fit needs to be just right. I don't want it really tight, because when I soft solder this part in place, I need the solder to find its way between the tank and the edges of this disc. Here I'm cleaning up the edges using a file once again, and after removing the disc and the modified boiler plug, here it is, and it's a perfect fit in the bottom of the tank. The next part of the job is to drill the hole in the side of the tank for the water valve. And just like in the series with the previous tank, I'm using a flapper wheel to clean up the burrs on the inside. Then I go all the way around to make sure that the copper is perfectly clean. I'm not applying too much pressure because I do not want to enlarge the hole in the tank. By making sure that all of the tank is perfectly clean, the soft soldered joint will be very strong. I've made a special bush. It's threaded 3/8 by 32 on the outside and 5/16 by 32 down the centre. I'm carefully cleaning up the external burrs on the tank, and this clip shows the aftermath of threading the hole in the tank 3/8 by 32 threads per inch. Here I'm withdrawing the tap. Now it's time to take the tank into the outer part of the workshop to soft solder it together. I haven't videoed this part. You can watch the soldering of a tank if you watch the main series, which is called a Model Steam Engine Test Plant. Although I did solder this tank in a different way, I used electrical multicore solder and just went around the edge. After doing this, it's the big cleanup operation using a variety of different methods. First of all, using a live centre and the large chuck of my Smart & Brown lathe, I spun the tank and used emery cloth to clean it up, followed by wet to dry sandpaper and finally some Brasso as shown here. Then I made a special adapter to mount the injector to the tank and screwed the complete assembly into the bush in the tank itself. Here are the two tanks side by side, and really they don't look much different in this clip, but they are. It is just the camera angle distorting the perspective. In this installation, I decided not to use a metal pipe for the injector's drain into the tank. Instead, I used a short piece of silicone rubber tubing, which does the job perfectly. This has definitely been a good day in the workshop. Not exactly a full day, but a good day in the workshop. In this clip, you can see the difference in the sizes of the two tanks. The first one, which is on the bench, is much smaller than the second one, which is now bolted in position on top of the overflow collector tank. And that's it for this episode. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.